payment endpoint returned 500 internal server error for malformed requests. The root cause, a missing validation error handler. Let's break down FastAPI error handling and custom exception handlers, how it works, and the exact mistake behind that failure. FastAPI error handling is the mechanism for intercepting exceptions and returning structured HTTP responses. Instead of wrapping every route in try-except, you register declarative handlers that receive the exception and return a JSON response. HTTPException is your first line of defense. You raise it with a status code and detail message, and FastAPI automatically converts it to a JSON response. You can also pass headers for machine-readable error codes. Here we raise HTTPException with a 404 status, a detail message, and a custom header. The header lets front-end code classify the error without parsing the detail string. For complex logic, standard HTTP codes aren't enough. Custom exception classes let you pass rich metadata from your business logic layer up to the global error handler. The handler then decides the HTTP status and response shape. Here we define a custom insufficient funds error with balance and amount attributes. The handler returns a 402 status with structured metadata, including the deficit. The endpoint raises this exception when the transfer amount exceeds the balance. FastAPI's default 422 response for validation errors includes internal field location tuples. Override RequestValidationError to flatten the structure into a simple field-to-message format that front-end forms can easily consume. This handler overrides the default 422 response. It iterates over the validation errors and builds a clean list with field name and message, making it easy for front-end forms to display errors. Not all exceptions are explicitly handled. Register a catch-all handler for exception to log the error internally while returning a safe, sanitized response to the client. Include a unique error reference ID for correlation. This catch-all handler logs the full traceback with a unique error ID and returns a sanitized 500 response. The error ID lets clients reference the issue, and you can find the log entry quickly. Error handling isn't just about returning the right status code. It's about knowing when errors happen. Integrate structured logging into your exception handlers to capture error context, request path, and timing for dashboards and alerts. This handler logs a warning with structured context including status code, detail, request path, and method. This makes it easy to track error patterns and alert on critical failures. Your exception handler runs happy path cleanup, but what about when a database connection hangs after a 500? Wrap resources in context managers before your handler ever sees the exception. FastAPI dependency injection supports yield. Use it. Here, the getDB dependency uses a context manager to ensure the database connection is closed even if an exception occurs. The finally block runs cleanup regardless of how the endpoint exits. Returning a string in detail is the lazy path. Define a standard error schema using Pydantic, code, message, details. Then write a single exception handler that transforms all your custom exceptions into that schema. Clients get predictable JSON. Here we define an API error Pydantic model and use it in custom exceptions. A single handler transforms all exceptions into this schema, ensuring consistent error responses across the API. This is the same issue we highlighted at the start. Here's exactly why that happened. The team assumed FastAPI's default 422 response for Pydantic validation errors would always be returned. But a middleware caught exceptions globally and returned a blanket 500 without distinguishing between validation errors and server failures. The default RequestValidationError handler was never configured. The payment endpoint returned 500 for malformed requests because no handler was registered for RequestValidationError, causing FastAPI to fall through to the generic exception handler, which returned a 500 instead of 422. The fix was to add an exception handler for RequestValidationError that returns 422 with a structured error array. Also added a catch-all handler for unhandled exceptions that logs the full traceback, but still returns a sanitized 500 with a unique error reference ID. This ensures validation errors are properly reported as 422, not masked as 500. If the catch-all handler is registered before specific handlers like RequestValidationError, it will catch all exceptions and return 500 for everything. Always register specific handlers first and the catch-all last. Without this override, front-end forms receive error objects with locked tuples like body, price, which are confusing. One team spent 3 sprints building custom parsing logic, all unnecessary if they'd overridden the handler. This is the exact mistake from the incident. Without a specific handler for request validation error, the catch-all handler catches all validation errors and returns 500, causing a 300% spike in support tickets. Always override request validation error to keep pedantic internals out of response bodies. Relying solely on HTTP exception without custom headers means front-end devs have to parse the detail string for error classification. Parsing strings is fragile. One typo breaks alerts. Always add an Xerror code header. Passing full database models and exceptions can slow down handler execution and leak internal state. Keep exception attributes minimal, only the data needed to format the error response. In FastAPI 0950+, exception handlers are stored in a dict keyed by exception class. If you register multiple handlers for the same type, only the last one registered is used. This is a change from earlier versions where handlers were stored in a list and evaluated in order. Always register handlers in a single consistent location to avoid surprises. The article mentions structured error schemas, but doesn't show a custom exception that directly carries a pedantic model. Here's how to define a custom exception that includes an API error model, making the handler simpler and more type-safe. When including metadata in error responses, like current balance, ensure you never expose sensitive information such as full account numbers, internal IDs, or database connection strings. Always sanitize exception attributes before returning them to the client. Use a whitelist approach. Only include fields explicitly defined in your error schema. Use these commands to diagnose error handling issues. Check if the request validation error handler is registered, test with curl to see the actual HTTP status code, and verify your custom exception class inherits from exception. Let's run through some common interview questions. How does FastAPI's exception handling middleware intercept errors? It wraps the ASGI app with middleware that catches exceptions and looks up registered handlers by type. Explain how to implement a global catch-all handler without masking critical 500s. Register at last, log full traceback, return sanitized response with error ID. What is the performance overhead of deep inheritance in custom exceptions? Negligible. Avoid serializing large objects in exception constructor. And a few frequently asked questions. What happens if I raise a standard Python value error? FastAPI returns a 500 unless you register a handler for it. How do I ensure consistent error responses across all endpoints? Define a pedantic error model and use a single handler for all exception types. Can exception handlers be async? Yes, handlers can be async def, useful for logging to external services. To recap, use HTTP exception for standard errors, custom exceptions for domain logic, override request validation error for clean validation errors, and always register a catch-all handler last with a unique error ID. Log everything with context. Ready to go deeper? Up next, PySpark tutorial, big data processing with Python, then FastAPI CLI, then FastAPI OpenAPI customization. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.